Next up, we have Dr. Ian, who will be giving a speech.
Okay, thanks very much. Well, good evening, and thanks very much for inviting me. It really is a great honour. I don't have slides. I've written a short essay for you, which I'd like to read. Imagine we could travel back in time to the early 1970s. By some accounts, the golden years of artificial intelligence research, and have a conversation with an AI researcher of that time. You know, in the 21st century, everyone's talking about AI. Oh, really? So, have you perfected deductive reasoning, solved part of speech analysis, and transformation to a semantic knowledge graph? Not really. We just built a kind of parameterized universal approximation function, mainly out of linear functions. You can't model general intelligence with linear functions and a few parameters. Well, the jury is still out on the general intelligence bit, but it works very well for vision and speech recognition. Needs rather more than a few parameters, mind you. Several million, typically. How can you possibly fit millions of parameters to an AI problem? Well, by using lots of training examples. Optimizing an error function by simple gradient descent. We have some pretty fast computers in the 21st century. Turns out your Gordon Moore, with his law, was spot on. Gradient descent on millions of parameters, that's crazy. You're sure to get stuck in local minimum. Well, that just turns out to be less of a problem than you'd think. So, do your AI machines, do they pass the Turing test? Maybe you thought we'd forgotten about Turing in the 21st century. No. Although we can pretty much simulate the average internet blogger. What's an internet blogger? A long story. Okay, so our 21st century time traveller was being a little coy and missed out some important details. Our optimization strategies typically use mini batches of training data at each step of gradient descent. This trivially speeds things up, but more importantly, it adds an element of randomness, hence stochastic gradient descent, which helps escape from those pesky local minima. And he didn't mention the key property, the secret sauce in our universal function approximators, namely that their simple construction allows for the gradient of the error, or loss, with respect to the parameters, or weights, to be calculated directly as a function of the training batch and current weights. Without this property, gradients would have to be determined empirically by central difference, with crippling impacts on computational costs. Another key trick, particularly important in imaging and speech and text, is the sharing of weights in a pattern that mirrors the spatial or temporal structure of the problem. Taken together, these differentiable, spatially weight-sharing, gradient descent-fitted, universal function optimizers are better known as, anyone? Convolutional neural networks, or CNNs. So neural networks are becoming a commodity technology. Readily available libraries such as Keras, TensorFlow, and Torch allow simple networks to be defined and fitted with just a dozen lines of Python code. We have become adept at doing clever things with these deep neural network building blocks. A network configured with an information bottleneck and trained simply to recreate the input signal forms an autoencoder, which can find a lower dimension embedding of high-dimensional data, a form of generalized PCA. A pair of networks can be made to compete, one network generating synthetic fake data, the other trying to discriminate fake from real. As training proceeds, each network challenges the other to improve. Some of you will recognize this setup as a generative adversarial network, or GAN. All the cute cat pictures you could want. At Canon Canon Medical, we're down in Leith, by the way, Canon Medical Research, obviously based in, the parent company is in Japan, but medical research is in Bonington Bond in Leith. So we're applying neural networks to a wide range of clinical problems. Excuse me. In chest CT, that's computer tomography, CNNs can segment diseased lung, differentiate patterns of interstitial lung disease, and detect lung nodules and vascular calcification. In head CT, networks which exploit anatomical symmetry can spot thrombosis and the extremely subtle signs of ischemia present in the acute phase of stroke. That is, the critical few hours after stroke onset, when prompt intervention can save brain and lives. Away from imaging, we are concerned with assigning precise diagnostic codes to free text medical notes, currently a time-consuming manual process. Our algorithms do not yet achieve performance matching the radiologist or clinician, and we believe the main reason for this is simply the shortage of available training data, somewhat contrary, as Guido was talking about, in other fields. Deep learning methods have voracious appetites. Obtaining access to data is problematic in the medical domain due to understandable sensitivities around patient confidentiality. Canon are leading a 3-year collaborative funded project funded by Innovate UK. It's called iCared. It's a collaboration between Canon and NHS, universities of Aberdeen, of Edinburgh, and several SMEs, small companies. And we are building an AI platform to allow algorithms to be trained within NHS safe havens, effectively taking the algorithm to the data, greatly reducing the risk of leaking personal health information, and so unlocking access to very large training cohorts, potentially in the millions. This will likely have a bigger impact on efficacy than any of our tweaks to network architecture or activation functions and the like. So the format of this evening kind of suggests that we on the panel should make some strong, potentially controversial statements to be shot at and perhaps serve as grist for the later debate. So I will make 2. I believe that we will soon be creating AI agents which we humans will care about in an emotional sense. This can only happen if these agents develop individuality. We have an Alexa at home and we find it useful, but we have no feelings towards it since it is identical to everyone else's Alexa. If the unit suffers a mishap and dies, I'll simply buy another. So why might creators of AI entities wish to engineer in individuality? Well, here's one kind of example. Kind of work with me on this. So I understand that chatbots are starting to be used to give basic legal advice. I read it on the interweb. So if I was to consult such an AI lawyer over a divorce or neighbour dispute, then I would expect it to maintain context between sessions, so I do not have to repeat myself. I would also expect it to observe client confidentiality. The other party to the dispute might be using the same model of AI lawyer, but our conversations must remain private. Nothing it learns during our consultations must leak across to other users. So my AI lawyer instance is specific to me and might usefully be given a name, Harold, say. Having invested time into briefing Harold on my case, I will be annoyed if he got lost or deleted and wary of Harold talking to other people. With increasing sophistication, perhaps by adapting to my level of legal knowledge or some crude show of empathy, then annoyed and wary might become a little like sad and jealous. I will be starting to care. My second prediction is something I've been saying now for over a decade, and perhaps is no longer controversial. I believe that the most sophisticated AI will emerge from a browser search box and probably be owned by Google. Other search engines are available, thankfully. Even before Google started overtly to invest in AI, the simple fact of their instant access to pretty much the entirety of human knowledge, i.e. the internet, puts them in a very strong position. They also constantly receive implicit training data from the billions of search terms and preview clicks that we all make every day. Internet search engines are already way more sophisticated than that humble term search implies. We've all experienced the uncanny way that Google finds just what we're looking for from the flimsiest of ambiguous search terms. And increasingly, it doesn't just present a list of web pages. It will often format and directly answer a question. It is becoming the universal oracle, already showing superhuman powers. Expect ordinary human capability to follow. The hype around AI is confused and misrepresented, certainly in the popular press. When one understands the working of neural networks, they can seem little more than clever filters, and a long way from achieving the general intelligence of an average human being, which Marvin Minsky in 1970 predicted would be achieved in about 8 years from that date. I can't help thinking that our visited researcher would have expected more progress in the intervening 50 years. Nevertheless, machine learning, AI if you insist, is changing every aspect of our life, and there is little sign of progress stalling. Early computers quickly surpassed us in doing arithmetic, then beat us at chess, Go, breakout. They are great at navigation, and they will soon be driving our cars. Actually, as I'm following Google directions driving my car, I sometimes feel like just a servo, really, and kind of, so bring on self-driving. And they will also soon be taking over the reading of routine medical images. Although I do not agree with Jeffrey Hinson's statement of a year or so ago that we should stop training radiologists. I would get shot if I said that. Of course, it is us humans who have programmed all of these feats, well now, for now at least. So is the hype in AI justified? I'd say yes, it is. Thanks.
Thank you, Ian. I suppose we'll gauge how controversial that is when it comes to Q&A. And last...